Good morning students. This is lecture 2 of our course. So, in this lecture we will today discuss about the need for the biomass based industries under a biorefinery concept. So, before discussing the biorefinery, so we will try to understand the basics of biomass. So, you know biomass is a renewable organic material usually which comes from your plants and animals. So, some of the important or most common you can say or maybe promising biomass feedstocks are grains and starch crops such as sugar cane, corn, wheat, sugar beets and sweet potatoes etc. Agricultural residues, corn stubble, wheat straw, rice straw, all these things. Then there are food waste basically coming from the food processing industry, and forestry materials, logging residues, forest thinnings. Then we will have animal byproducts, tallow, fish oil, manure etc. Then we have dedicated energy crops which are there are specific energy crops. So, some of them are switchgrass, miscanthus, then we have poplar, willow etc. and of course, algae. Then urban and suburban waste. So, under this MSW comes here municipal solid waste. So, lawn waste, wastewater treatments laws and there are many other things also. So, what is the actually importance of the biomass energy and why we are discussing? Last class during our introduction we have understood that what is the importance of biomass based energy and biomass based industries. The global energy picture is changing rapidly in favor of renewable energy. So, according to IRENA's global renewable energy roadmap which is called the REMAP 2030, if the realizable potential of all renewable energy technologies beyond the business as usual are implemented, then renewable energy will be accounting for almost 36% of the total global energy mix by 2030. Okay. So, if all the governments according to their policies and implement it, then this is going to happen. So, this would be equal to doubling of the global renewable energy share with compared to 2010 level. So, then biomass has an auspicious feature. So, by 2030 biomass could account for 60% of total final renewable energy use, as biomass has potential in all sectors. So, biomass based energy, then other value added chemicals or value added products can be used, okay. So, across all sectors. So, that is the beauty of biomass actually. So, most biomass demand today is its traditional use for cooking and heating. As of now also, today also, so whatever the biomass is being utilized, it is more basically for the traditional use for cooking as well as heating. So, in 2010 more than 60% of the total global biomass demand of 53 exajoules was used in residential and commercial building sectors. Much of this was related to traditional use of biomass for cooking and heating. Biomass demand in the manufacturing industry is almost 15%, transport sector is 9% and the power and district direct heating actually it is 8%. So, this is about almost about 1/3. So, biomass applications could change over time. So, global biomass demand could double to 108 exajoule by 2030 if all its potential beyond the business as usual is implemented. So, that means nearly a third of its total will be consumed to produce power and direct heat generation, about 30% would be utilized in biofuel production, mostly for the transport sector, and the remainder would be halved between heating applications in the manufacturing industry and building sectors. So, biomass used in the combined heat and power CHP technology is basically will be key to raise its share in the manufacturing industry and power sectors. Then estimated global biomass demand according to the REMAP 2030, the United States, China, India, Brazil and Indonesia, these are the 5 countries, these are the 5 big economies also of the world. Okay. So, they are going to account for 56% of the total biomass demand by 2030. So, global biomass supply in 2030 is estimated to range from 97 exajoule to 147 exajoule per year. Approximately 40% of this will originate from the agricultural residue. So, there lie a very important information about the agricultural and forest residues and waste materials basically. So, the remaining supply potential is shared between energy crops 33 to 39 exajoule and forest products including forest residues. So, the largest supply potential exists in Europe and Asia including Russia. So, this is another interesting thing is that these countries are blessed with huge biomass reserve. So, that is why they will be the potential feedstock suppliers basically. So, international trade of biomass would play an important role in meeting the increasing global demand. Trade account for between 20 to 40% of the total global demand by 2030. Domestic supply costs of biomass is estimated to range from as low as USD 3 for agricultural residue to as high as USD 17 per GJ of the energy crops. There are many challenges to be addressed in the biomass demand and supply. Having said that biomass energy, biomass is everything, it is good for economy as a biorefinery concept and all, everything is fine. But having said that, we need to understand that there are many challenges that needs to be addressed for the biomass demand and supply. That is the most important bottleneck actually. So, it international trade as well as substitution of its traditional uses in realizing such high growth rates. So, if you keep on using the biomass for the cooking purposes and heating purposes, so then this is not going to help us in a roadmap. Basically, if you think about a 2030 2035 roadmap which most of the countries have agreed to. Okay. So, what we have to do is basically the bioenergy demand estimated to be double between 2010 and 30, ensuring that sustainability of biomass will gain even more importance including environmental, economic and societal aspects. Now, for a sustainable and affordable bioenergy system, existing national and international initiatives and partnerships as well as energy and resource policies need to be expanded to address the challenges across the biomass use and supply chain. Now, while biomass represents an important stepping stone in doubling the global renewable energy share, potential of other renewable energy sources basically should be or must be expanded. Okay. So, it should be an integrated approach rather than only biomass and biomass, that is not going to help in a sustainable way, right. So, for that we need to expand on or work on our government policies, okay, including subsidized many of the installation facilities, transportation and of course, the tax will also come into picture. So, biomass energy has rapidly become a vital part of the global renewable energy mix and account for an ever growing share of the electric capacity added worldwide. So, now most importantly, last class also we have discussed that biomass based electricity generation, okay, and directly feeding it to the grid. So, these are the upcoming things and it is happened, it has already happened. So, it is happening in many countries and will happen in India too very soon. Okay. So, traditional biomass primarily for cooking and heating represents about 13% and is growing slowly or even declining. So, declining is a good thing for it, but we must declining as well as declining in these traditional uses as well as their use in more sophisticated modern biomass based industries, then it is going to help us. So, some of the recent predictions suggest that biomass energy is likely to make up 1/3 of the total world energy mix by 2050. Okay. So, in fact, biofuel will provide right now biofuel is providing almost 3% of the world's total fuel for transport, liquid fuels basically, okay, or maybe some gaseous phase sometimes, right. So, biomass energy sources are readily available in rural and urban areas of all countries. Biomass based industries can foster rural development, provide employment opportunities and promote biomass regrowth through sustainable land management practices. This is another important thing. Now, where let us understand that we talk about dedicated energy crops, okay, like this I told you. So, like maybe it may be poplar, it may be switchgrass, miscanthus, whatever it is. Now, for that if when I need to cultivate them, I need to grow them, I need to plant them. So, where do I plant? So, the available land for agriculture is day by day decreasing across the world due to more and more urbanization. We know this, okay. It is happening in India also. So, But we need to understand that when I wish to grow this type of energy crops, then I should not use our prime agricultural lands, rather than I will use such lands which are barren or are not suitable for growing the food crops. We can use and a little modify them, upgrade them and use for this energy crops, then things will be very nice. Otherwise, there will be a sustainable land management issue will come into picture. So, the negative aspects of traditional biomass utilization in developing countries can be mitigated by promotion of modern waste to energy technologies, which provide solid, liquid and gaseous fuel as well as electricity. Another hot topic nowadays is about conversion of the waste to energy. You might have heard about this waste to energy many times. There is another term which is called water energy nexus, that also is very upcoming. Okay. So, let us talk about waste to energy. So, most of the wastes biological nature, okay, can be converted into energy. Now, having said that, there is one technology, of course, we will discuss in detail in one of our lectures later on when we discuss about the thermochemical aspects. So, I will just tell you in a nutshell, thermochemical conversion technologies, one such is gasification, then we have our pyrolysis. So, these are beautiful technologies. If you adopt that, you get 3 different types of biofuels. One is the liquid biofuel, one is solid biofuel, another is the gaseous biofuel. So, these technologies are available. So, only we need to upgrade ourselves to suit a particular feedstock, or rather I can say that technologies should be developed in such a way that they can process multiple feedstocks. That is the challenge basically. So, the most common technique for producing both heat and electrical energy for biomass waste is direct combustion. Now, thermal efficiency as high as 80 to 90% can be achieved by advanced gasification technology with greatly reduced atmospheric emissions. Then of course, CHP is there, the combined heat and power system, ranging from small scale technology to large scale grid connected facility. This is what I was telling you, just technologies are available, and now what is the emphasis is given? Emphasis is mostly given on how to generate electricity from biomass and connect it to the grid. Okay. So, biochemical processes like anaerobic digestion and sanitary landfills can also produce clean energy in the form of biogas and producer gas, which can be converted to power and heat using a gas engine. Now, let us talk about what are the advantages of biomass energy. Okay. So, bioenergy systems offer significant possibilities for reducing greenhouse gas emissions due to their immense potential to replace fossil fuels in energy production. Biomass reduces emissions and enhances carbon sequestration, since short rotation crops or forests established on abundant agricultural land accumulate carbon in the soil. So, this is also very interesting, that is because we know that biomass are we can say that they are carbon negative. The reason is that, let us say whatever this one carbon dioxide we generate by burning the fuels, even if it is a biofuel. Okay. So, that goes to the atmospheric. Again we say that this carbon dioxide will be utilized by the same feedstock materials when we are growing them. Basically, it can be any energy dedicated energy crops or any plants or maybe forest as a whole. Okay. So, that is how the carbon cycle is supposed to be managed, and bioenergy usually provides an irreversible mitigation effect by reducing carbon dioxide at source, but it may emit more carbon per unit of energy than fossil fuels unless biomass fuels are produced substantially. So, this is what is again need to be understand, that unless until we produce biomass based fuels in a huge quantity, or else what will happen, that we will be end up in producing more carbon dioxide than we are consuming the same, okay, consuming the carbon dioxide. So, biomass can play a major role in reducing the reliance on fossil fuels by making use of thermochemical conversion technology. I just mentioned about it. Of course, we will discuss more in our subsequent lectures. So, in addition, the increased utilization of biomass based fuel will be instrumental in safeguarding the environment, generation of new job opportunities, sustainable development and health improvements in rural areas. The development of efficient biomass handling technology, improvement of agroforestry systems and establishment of small and large scale biomass based power plants can play a major role in rural development. So, another important thing we need to understand is that the collection of such agricultural or forest waste, what we are talking about basically for the biomass based industry, is not that easy. So, rural people can be engaged for doing that, and there are many concerns about the transportation of such wastes to a plant where we will convert them basically to the liquid or gaseous fuels, right, or we generate electricity. So, if we can locate the plants very near to the rural areas or the forests where these materials are being collected, then it will be a win-win situation. So, we will save a lot of money in transportation, as well as the rural people will get some jobs, and there will be some community development also. So, when compared with wind and solar energy, biomass power plants are able to provide crucial reliable base load generation. This is more important. This is basically when we are talking to connect it to the grid. Okay, there should be a proper sustainable supply. Otherwise, what will happen? Today you are supplying one particular rate, tomorrow it will fall. That is not going to help in a sustainable way when we talk about grid connectivity, right. So, biomass plays a better role with respect to wind and solar. So, a large amount of energy is expended in the cultivation and processing of crops like sugarcane, coconut and rice, which can be met by utilizing energy rich residues for electricity product. Now, some of these processing we know they use huge energy, sugarcane, coconut, rice mills, all these things. Okay. So, what is being suggested is that there is a sugarcane waste which is called bagasse. Okay. Then there are coconut waste, then there is rice straw, all these waste. If those waste which are generated at the site can be converted, okay, using suitable technologies by to heat or energy or any such thing, and maybe electricity, maybe a small scale gasification plant can do this one, a lot of it would can save a lot of money basically. So, basically it is an integrated approach. So, the waste generated and at a source and treated and consumed or converted in the same source to value added products, or we can say that maybe to energy. Okay. So, that approach will help us a lot. So, the integration of biomass fueled gasifiers in coal fired power stations, this is what is basically okay, would be advantageous in terms of improved flexibility in response to fluctuation in biomass availability and lower investment cost. So, if you couple biomass fuel gasifiers along with the coal fired power station, so it will help us two things. First is that it will address the availability of the biomass around the year, because coal is available to generate power. Second thing is that we will reduce the use of coal, thereby reducing the carbon dioxide generation. So, look at this particular biomass demand this one plot. This is extrapolated to 2030. Just look at this last. Okay, look at this. So, this Indonesia, then Russia, Brazil, India, China, United States. Okay. So, these 6 countries mostly, even if you can consider Canada also, but I am just counting these 4-5 countries. So, just look at this particular plot. You can see that United States, China, India and Brazil, these are the 4 major contributors, or let us say the more their demand for biomass is more. Okay. So, with comparison to the rest of the world, because these countries have huge biomass reserve, as well as they have realized the potential of the biomass based fuels, energy and of course, industry also. So, this is by region. So, again you see Asia, the huge one here. Okay. Basically, the contribution is coming mostly from the China, India and Indonesia. Okay. Then Europe, North America, and North America also United States only, and there are Latin America is also there. Okay. So, mostly it is coming the you can see that from harvesting residues here in the Asia, in which India falls basically. Then we have processing residues, okay, and of course, then we have fuel wood and wood residue, as well as wood waste. Energy crops is very less in Asia, however, it is high in Europe, America and other countries, okay, because they have started cultivating the dedicated energy crops, right. We are slowly adapting it. Then having said about the biomass based industries, the advantages of bioenergy and all these things, let us now understand what are the challenges, okay, related to biomass. So, the existing challenges of biomass supply chain related to different feedstock can be broadly classified into 4 things or 5 things. First is actually operational, then is economical challenges, then is social policy matters, and then regulatory challenges. Okay. We will see one by one. What is operational challenges? So, feedstock unavailability. So, inefficient resource management and the government non-intervention approach are the key factor hindering the expansion of the biomass industry. Feedstock of biomass should be in such a way that it should be available in a sustainable way throughout the year. But can we ensure that? Let us understand that I am talking about straw, rice straw, okay, or any such bagasse for say bagasse also. These are seasonal crops, okay. Any such crops are seasonal, we need to understand that. So, of course, their generation of waste is also seasonal. So, can we produce so much of waste so that we can keep it or store it for the year the round application? It is the answer right now is no, at least for the Indian context, but we need to work on that. There are policy matters, government should interfere and make policies in such a way, okay, and there should be technologies or this one should be developed in such a way that we can store these waste for a long term use. Okay. Right now that is not happening. So, regional and seasonal availability of biomass and storage problem, this is what I already told you. Then pressure on transport section. So, because the biomass contains a huge amount of moisture, right. So, that is why transporting waste biomass from the plantation to the production site becomes energetically unfavorable and costly with the increase in the distance, basically distance between the collection site as well as the plant. So, then inefficiency of conversion facility, core technology and equipment shortage. Now, technical barriers are resulted from the lack of standards on bioenergy systems and equipment, especially where the energy sources are so diverse. Appropriate pre-treatment required to prevent biodegradation and loss of heating value not only increases the production cost, but also in equipment's investment. So, there is something called pre-treatment, we will discuss in our subsequent lectures what is pre-treatment and how what is the importance of it. Okay. So, we need to pre-treat the biomass according to where they are going to use, basically whether it is going to be a thermal conversion technology or a biological conversion technology or what that. So, depending on that we need to treat biomass, okay, pre-treat biomass, basically fractionation and size reduction, and there are other things also. So, then immature industry chain. So, it is virtually impossible to get long term contracts for consistent feedstock supply in reasonable price. So, industry will only be interested if I am going to supply them throughout the year in a sustainable way the feedstock, okay, the particular feedstock. Everybody is interested for a particular feedstock, okay. So, that is not going to happen, right, but policy should be framed and it should be implemented in such a way that industry. So, we basically we should favor the industry by implementing such technique. Then economic challenges. So, feedstock acquisition cost. The biomass resources are scattered, and in order to reduce the cost of transportation, biomass projects are eager to occupy land close to the source, leading to centralization of biomass projects. Then limiting financing channels and high investment and capital cost. As of now, the industries which are implementing them, I can tell you that there is a huge cost which is required basically for the capital investment, okay, procuring the equipments, installation, the land cost, okay. Forget about the running cost and all these things and manpower cost, okay. So, here the government has to intervene and make policies in such a way that there will be GST credit and there will be this one less tax, okay, on procuring equipments, and of course, there are other things and apart from the subsidies. Then social challenges. So, under social challenges there are few things. First one is the conflicting decision. So, decision making on selection of supplier, location, routes and technologies is crucial, okay, needs proper communication. So, basically which supplier you are going to choose, whether it is reliable or not, where it is located, where is my plant located, what are the routes or distance, how much it is going to cover for the transportation of the feedstock from the procurement side to my plant and technologies. So, we need to have a proper decision making system for that. So, land use issues. So, land use issues leads to the loss of ecosystem preservation and the homes of the indigenous people. That is why I was just mentioning that we should use such lands which are not at all used for the dedicated food crops. Then impact on the environment. So, the biomass plantation depletes nutrients from the soil, right. So, promote aesthetic degradation and increase the loss of biodiversity. Other social impacts will result from installation of energy farms within rural areas like increased need of services, increased traffic, etc. The potential negative social impacts appear strong enough to ignore the benefit of new and permanent employment generation. So, if we try to develop a rural based bioeconomy, then most of these issues will be addressed. Then let us talk about the policy and regulatory challenges. So, at present the government is subsidizing the domestic fuel price, which in turn makes the electricity generating cost from conventional sources lower than the power production cost from renewable sources, and this is exactly what is expected from the governments, not only from the government of India, but from government of the all other countries also, and they are doing it. So, there are no specific rules to regulate the work of utilization of biomass resource, and there are no specific penalties for not using behavior that should be comprehensively used. Okay. So, basically its policy guidelines has to be there. Government should come up with clear cut policies and guidelines, what to be done, what not to be done. If you are doing something which are not expected or will result in some environmental concerns or social concerns, okay, then you need to be penalized. So, as such now such policies are not available, but I know that they are coming. Okay, soon it will be implemented in India as well as other countries also, and there is no special mechanism to manage the development of the biomass resources industry and no specialized department to manage the implementation of relevant national standards and policies. So, all these things are comes under the government's these are government's job basically. Okay. So, and I know the governments are actually coming up with so much of policies for the biomass based industries, and so there are already some existing policies, but more need to be done and it is being done actually. So, let us now understand the supply and demand framework of bioenergy. You can see this particular slide how it is being actually depicted here. So, the land demand, land use and energy production. So, the land demand is basically in all countries is basically for the food demand, based on the food demand. So, growing the and food crops, and of course, for the wood demand, that means it is for the either it is a industrial demand or it is forest, basically forest. So, then when we talk about use, so the domestic production is basically for the food and industrial wood, firewood and all these things plus international trade, and the remaining land is being or can be utilized for the energy crop. So, this one, okay, the remaining land should be utilized for the energy crop and surplus firewood is also there. Okay. And the energy production from the biomass residue, harvesting residue, processing residue, animal waste, household waste, all these things. Then primary bioenergy will come from the this dedicated energy crop. So, like from sugar crop, sugar cane basically starch, oil crop and cellulosic crop, other cellulosic crop. So, if you look at the current land use and suitable area for agriculture, so this is the land use in 2010 and that's one is the potential for the crop production. So, you can see that right now the forest is 4 billion hectares, then crop production is going on in 1.5 billion hectares. Okay. And here if we are talking about the projection, the suitable and available area that will be basically for the crop production, dedicated energy crop production or biomass production will be almost around 2.7 billion hectare. Okay. So, there will be a 1.4 billion hectare surplus that will be available land, those can be utilized. Okay. So, let us understand the relationship between the players along the value chain. This is very interesting and very important, where you can understand that every one of us has a role to play in this business basically. So, the policy maker, they will decide the policies, they may give financial support and all these things. Then there is something called a researcher, where people like me and some of you are coming into picture. Okay. What they do, they are all integrated into various sectors, whether it is a supplier, whether it is the manufacturer, whether it is a customer. Okay. Researcher has a big role to play in every sector. Okay. So, then there is a logistic, raw biomass storage and transportation, and there is the logistic which is related to the bioproducts processed products, basically transportation, and take them to the reach of the common people or say the customer. Okay. So, the researcher has a lot of role to play in the entire system, this biomass based industry or processing industry sector. Let us talk about the life cycle of biomass industry. So, please see where we are heading. We are now here in the current status. Okay. You see the red one here. Okay. So, that is between the initialization phase and the growth phase. We means I am talking about especially India. Okay. So, we have started for the fuel from the thermal energy sources, electricity. Okay. Electricity has been implemented hugely in our country. Still there are many villages and rural areas where the electricity is not reached. It is going to be implemented very soon. Government of India is doing that. Okay. So, then we move to the growth phase. In growth phase, what is available? So, basically there will be increasing demand due to urbanization and industrialization of electricity, okay, or you can say the energy, and there will be low to high value added products that will come into picture when we pass from the initialization phase to this particular growth phase. So, those products can be fertilizers, that can be fiber, that can be platform chemicals, that can be other value added products, right. Then we go to the maturity and decline stage. When you go to the maturity stage, we have a constant demand. Okay. Now, our demand is basically increasing. The moment you reach here, there will be a plateauing effect, and we will have a constant demand, because we have reached to a mature stage. Okay. And more or less our industrialization, or let us say the urbanization, has saturated. Okay. So, we go for very high value added products like biochemicals. Then after that there may come a decline stage, where there will be a reducing demand, okay, and there will be no more product innovation happening. So, here this is the stakeholders interaction and role in commercialization of biomass conversion technology. So, in one of the slide, just 2 slides before, we have discussed how researchers are playing a role. Here also you can see that the researchers, the top one you see the A, how they are being integrated themselves into various other people, okay, basically the supplier, customer, industry and the government. They are completely integrated themselves along with all other stakeholders. Okay. So, what they do, researcher will resolve the upstream issues, harvesting issues basically. So, they will provide strategies to meet the national goals as mentioned by the their governments. Then provide strategies to satisfy the customer needs, and they will provide technical know-how and experts. Okay. Then the supplier, what the supplier is supposed to do? So, supplier will provide raw material and share information, they provide service that meet customer need, they will obey the regulation and policy setup, okay, and it is a long term collaboration, because. So, when I talk about long term collaboration, that means it is a consistent supply, right. And what the government will do? So, government's job is to provide research funding, government job is to regulate the biomass pricing and legal enforcement. Then government must promote the importance of sustainable development, and government should go for financial support, whether it is an incentive, subsidy, tax exemption like GST credit, and all these things will be there. Then there will be customer. So, the customer, what is their job? So, publicity and provide data, basically feedback, they should give a feedback, right. So, support green suppliers, support green products, provide feedback, this is what I already told. And then the industry, the most important. Okay. So, adopt research, innovative ideas and share information, they should have a long term collaboration, okay, looking for a consistent demand, basically they should be able to meet that demand. Then they should generate products that meet customer needs and obey the regulation and policy setup. So, you can understand in this particular slide how all the stakeholders, all of us, you, me, government, the suppliers, then this is the industry people, okay. So, all of us have a role to play as a stakeholder in this particular biomass conversion business. Okay. Let us understand the problems of biomass large scale supply. So, one of the biggest problems related to biomass large scale supply is the energy density. So, briefly, if biomass moisture of conventional wood is 30%, what it means? That means every 1 ton of wood or the biomass that I transport, I am transporting almost 300 kgs of water. So, it is a huge, it is a waste basically, and I am paying a heavy price for the transportation. Okay. So, additionally biomass feedstock shape. Okay. So, it is also very important. So, whether it is chipped, pelletized, rounded, bulked, all these things will strongly influence the bulk density and affect the transportation economics. So, we should also look into that. Then in addition to the bulk and energy density, large scale biomass supply is affected by a wide range of bottlenecks, including raw materials initial cost, biomass producers involvement, environmental regulation and sustainability. Now, finding solutions for all these problems means finding the solution for the creation of the future biomass commodity in worldwide. So, there are problems of course, but there are solutions also. So, let us understand what are the problems and what can be the solution. So, a high quality biomass is considerable, but limited, expensive and not always sustainable. So, what can be the solution? So, utilization of agroforestry residue, that can be a sustainable solution. High availability is there and fully environmentally sustainable, right. What is the other problem? Now, agroforestry residues have lower quality and higher micro elements, that is true actually, right. Calcium, magnesium and all these presents minerals compounds basically. So, what can be the solution? Now, blending of different biomass feedstocks to arrange suitable average composition, right. So, do not go for a single stock, it is not going to help us in a sustainable way. So, we should always go for multiple feedstocks, right. So, that is why the technology should be developed in such a way that we will basically our process our this one equipment, or let us say the process itself is capable enough to take away the multiple feedstocks. Okay. So, because multiple feedstocks will have different feedstocks will have different composition. So, you can play around and mix the composition in such a way that we will have a average composition that is good enough for producing the energy, or let us say other value added products. So, availability is mainly reduced to forest areas. Now, residues have much more lower cost and dispersed and available in almost everywhere. So, if you talk about the municipal solid waste, okay, food processing waste, industrial waste, then the dependence on only forest waste will come down. Then low energy density and bulk volume of fresh biomass affect storage cost and transportation. This is what we just discussed in the previous slide. So, the activities what we need to do is that you go for a chipping, okay. Activities enhance biomass storage density, dry them, but again energy is coming into picture. Okay. So, it is always advisable to reduce the transportation cost. So, how do you do that? So, locate the biomass industries in such areas where there is a huge biomass reserve basically. Then biomass degradability affect large distance transport activities, long term storage. So, agri pellets production, you produce pellets from the biomass and it is easy to transport, the density will come down, okay, with low moisture and high energy density, avoiding degradation and transportation issues. So, these are some of the major problems which are associated with the biomasses and what we can and how we can address them suitably basically. So, let us now understand what is a biorefinery. Okay. So, I will show you 2-3 slides to understand what is biorefinery, then we will discuss about the biomass based biorefinery things. Okay. So, facility that integrates biomass conversion process and equipments to produce fuels, power and chemicals from biomass is called a biorefinery. Okay. So, it can be classified by several categories, by feedstock materials, by resulting products, by technologies that utilized, by combination of all these three also. So, biomass feedstock categories by chemical composition may be carbohydrates, lipids, proteins, lignocellulosic materials. So, resulting product categories may be biofuels, chemicals, biogas, electricity and heat, and technologies and unit operations employed include fermentation, gasification, pyrolysis, hydrothermal liquefaction, it is a very upcoming technology actually, hydrogenation, hydrothermolysis and oxidation and hydrodeoxygenation. So, some of the feedstock that has been tested, I have just listed few, there are many, okay. So, list is endless basically. So, cultivated crops, agricultural waste, forest resources, urban and industrial waste and microalgae. Now, algae is something interesting, we will discuss about algae later on. Okay. So, microalgae have a great potential as a feedstock for the production of a wide range of end products under the broad concept of biorefinery, and algae can be used for the production of biofuels and a variety of value added chemicals, since they possess high amount of lipids, proteins, carbohydrates, vitamins, pigments and enzymes. So, the importance of biorefinery for bio-based industries. So, the International Energy Agency's Bioenergy Task 42 defined biorefining as the sustainable processing of biomass into a spectrum of bio-based products, right. So, it can be food, feed, chemicals and materials, as well as bioenergy, that means biofuels, power and or heat. So, as refineries, biorefineries also can provide multiple chemicals by fractioning an initial raw material, which is biomass in this case, into multiple intermediates. So, it can be carbohydrate, proteins, triglycerides that can be further converted into value added products. Each refining phase is also referred to as a cascading phase. Now, biorefinery involves the enabling technologies to make this possible, as it allows for optimal utilization as well as value creation of biomass. Development of integrated closed loop biorefineries that ensure their sustainability and economical viability through a complete use of biomass, minimize waste and generate the greatest possible added value from the available sources. What is this integrated closed biorefinery? Is that let us say it is a biomass based refinery. I am going to use 1 or 2 feedstock. Okay. I process them, I produce electricity or maybe liquid biofuels or maybe steam. Okay. If I am going for some steam based power generation or some other commodity products or value added products. Now, thereby I also produce a huge amount of wastewater, because water is required every stage of processing. So, having said that, the water availability, the fresh water availability is day by day it is reducing across the globe in various places. We know that in India also it is a huge problem in few areas. Okay. So, what is the need of the hour is that how do we treat and recycle this wastewater, okay, in a closed loop system. Thereby, that means, if we do that, then we will be depending less on our fresh water resources. Okay. That is what is the need of the hour, right, because time will come that there will be very scarce water available. So, how we will run a refining process, whether it is a biorefining or petroleum crude based refining, it consumes huge amount of fresh water. So, we should look for a integrated closed loop biorefinery. That means, whatever waste that we are generating, it can be solid waste also. I am just talking about liquid waste, basically the wastewater. It's let us not talk about only the liquid waste, let us do something to the solid waste also. Whatever solid waste we generate, can we further process them to get fuels out of that, or can we further process them to get some value added products from that? If you do that in a closed loop biorefinery circle, then the biorefinery will become economically sustainable and will be a viable option. So, the new biorefinery concept overcomes the problems arising from the generation of residues by giving them new value. This is how a significant increase in profitability and competitiveness of our petrochemical equivalents will be achieved. Otherwise, petrochemical based fuels and products will be always low cost than whatever we produce from the biomass, right. So, the profitability and competitiveness has to be taken care of also. So, we go for multiple products. What is the answer for that? We go for multiple products. Do not aim only for the fuels or energy, but you please look for other products also. Okay. So, biorefining is the main element in the framework of emerging bioeconomy as a broad spectrum of biomass resources that offers great opportunities for a wide ranging product portfolio to satisfy the different needs of the society. So, as I told you, unless until we go for multiple products, unless until we go for and work for a waste to energy or water energy nexus, and how do we convert waste, in-house generated waste from the refining process, whether it is solid or liquid, and get some value added product out of that, we are not going to have a sustainable and economically viable biorefinery. Okay. So, Currently, some biorefineries are operating on a commercial scale, pulp and paper industry, biofuel industry and food industries. Furthermore, many different newly advanced biorefineries are under development. So, the main characteristics of a biorefinery are there should be coupled generation of energy, gaseous and liquid biofuels as well as materials. It can be chemicals, food and feed. Right, a combination of several process steps. It can be a mechanical processes, it can be thermochemical processes, it can be biochemical processes also. So, and use different raw materials from both virgin as well as residual sources, that is also very important. Okay. So, a common hurdle in commercialization of biorefinery is its economic viability. The economic hurdle starts from procuring biomass and its logistics, technology maturity and policy support. This is what we have already discussed. Okay. So, the rate of commercialization of biorefineries is slow, primarily due to the lack of policy support. This I already mentioned that the government has or should come up with policy which will support the establishment of biorefineries. Okay. So, biorefineries have to compete with well established petrochemical products. Policy support can drive innovation, help a technology to mature, create competitiveness to a market which in turn could reduce the cost, thus making the economic viability of biorefineries as a reality. Government has a big role to play, right. So, this is how it looks like. Basically, you have a biomass here, you process, okay. In the biorefinery we have downstream processing, you have which is called separation technology, it can be catalytic conversion, it may not be, then we get this type of products, fuels, solvents, bulk chemicals, plastics, fibers, fine chemicals and oils and what not. Okay. You can just see what not we are getting from the biorefinery. Okay. But it is again true that one particular feedstock will not give me like this. So, we should go for multiple feedstock, okay. And as well as not only virgin feedstock, but also processing feedstocks, okay, or processing wastes. So, before I wind up, I just quickly show you or will glance through the different bio-based industries that are actually established and running successfully. Blue Marble Energy, okay. So, that is in Odisha and Mizola. Then Canada's first integrated biorefinery developed on anaerobic digestion technology by Himark Biogas, that is in Alberta. Then Chemrex technology for black liquor gasification and production of second generation of biofuels such as biomethanol or bio-DME, okay. That is integrated with a host pulp milk and utilizes a major sulfate to sulfide process waste product as the feedstock, completely waste product based biorefinery. Okay. Then Novamont has converted old petrochemical factories into biorefineries. This is a very interesting thing actually basically. So, but just changing some of the processing things, some equipments and all, they are running this refinery in a sustainable way. C16 Biosciences, they produce synthetic palm oil from carbon containing waste. Then there is Macro Cascade that aims to refine seaweed into food and fodder. Okay. And then products for healthcare, cosmetics, fine chemical industries, and there are other they process other things also. Fumi ingredients that produces foaming agents, heat set gels and emulsifiers, what from microalgae. Okay. So, with the help of microorganisms such as Brewers yeast or Baker's yeast. Biocon, it is an Indian company. Okay. So, they are processing the wood into various products. More precisely, their researchers are looking at transforming lignin and cellulose into various products. Lignin based biorefineries are also there. Okay. So, lignin for example, can be transferred into phenolic components which can be used to make glue, plastics and agricultural products, crop protection. Cellulose can be transferred into clothes and packaging. Now, in South Africa, there is a company called Numbitrax LLC. They have bought a Bloom biorefinery system for producing bioethanol as well as additional high return uptake products from local and readily available resources such as prickly pear cactus. It is a plant basically. So, then Bitebake insect that makes insect cooking oil, insect butter and all these things. Then there is a company called Circular Organics, that is a part of Kempen Insect Valley that grows black soldier fly larvae on waste from the agricultural and food industry. Okay. So, fruit and vegetable surplus remaining waste from the fruit juice and jam production, basically the solid waste. So, these larvae are used to produce protein, grease and chitin or chitin. Okay. So, the grease is usable in the pharmaceutical industries for cosmetics and surfactants for shower gel, thereby replacing other vegetable oil as palm oil, or it can be used in the it as a fodder also. So, with this I complete my lecture today. So, thank you very much, and in the next lecture we will be we will start module 2 basically. The module 2 is focused on biomass. So, we will be discussing the availability and abundance of biomass, photosynthesis, composition and energy potential, virgin biomass production, agricultural forestry waste and all these things, their availability and their potential. So, thank you very much once again, and if you have any query, please write to me at kmohanty@iitg.ac.in, or you can also write to me in the SWAYAM portal. Thank you.